Lecture-5
So we are in the syllabus of the identification of acidic radical. So in the acidic radical, the main groups are three groups. First group is dilute acid group. Second group is concentrated acid group. In the second group, we are here. In the second group, majority of the group elements are from the halogens. Majority of the group elements are from the halogens. Up to now, we have studied about the Cl minus. So we have divided this into the how many parts? Two parts. First, physically, what we will observe, and after that, chemical reaction explaining our observation. Okay. First, let us see about the Br minus observation. First observation, when it is heated with, in this test, what we will do, we will heat with the concentrated acid. Given salt is heated with the concentrated acid. So on heating the salt with concentrated acid, brown vapors evolves. But the problem is that brown vapors may be due to Br minus or due to one more example also I have told. What is that? In previously, brown vapors, evolution of brown vapors is due to, very nice, it is due to NO2. So it can be because of the NO2, it can be because of the Br minus also. So that is the main problem with this observation. Okay. So still we are not confirmed that bromine minus will be available because of the similar color. So there are some more tests to be carried out. Okay. And these are not much different tests, very old test only. When treated with AgNO3, similar test is done for which acid radical. Reaction with AgNO3 test is already done with one of the acidic radical. To identify which acidic radical, AgNO3 is added. Very nice. Cl minus. Okay. So if chloride minus is there, to identify, AgNO3 is added. Where you will get what type of observation? You will get white precipitate observation. What will be the observation? White precipitate observation. Okay. But this Br minus, if it is present, in place of the white precipitate, we will get light yellow precipitate. Okay. What is the reason? That I will give you through the chemical equations. Okay. And after that, to further confirm, we have added what substance? Ammonium hydroxide. Here also we are adding the NH4OH. Okay. So, but there it was soluble in NH4OH. But this is the main problem here also, is that light yellow and white. So very similar colors, white color and light yellow. To further confirm that it is Br minus only, solubility test is carried out. Okay. If that light yellow precipitate is partially soluble in ammonium hydroxide, it is definitely Br minus. Okay. First, if it should give the brown vapors when treated with the concentrated acid. Second, when the given salt is treated with the second test is given salt is treated with AgNO3. Second second step, salt is treated with AgNO3. It will give the light yellow precipitate. To differentiate between white and light yellow is difficult. So further confirmed by adding the NH4OH. NH4OH, if it gives partially soluble, that means it is bromine. Okay. And to avoid these two confusion, the brown vapors which we get in the first step, when passed through the H2O, they will give the brown coloration. So if it is NO2, no coloration. Okay. If it is NO2, no coloration. Observations, is it clear now? First, what we have to do, we have to react the given salt with concentrated acids. So brown vapors are emitted. I am going to give you one model question, one or two model question after this. Okay, so we are in the acidic radical and about to finish off. After finishing off, the main problem with this topic is without questions, only understanding and remembering will not be useful. How this type of questions will be framed by in between, that's why I'm asking, so that you should recollect and you should remember them in the proper manner. Okay, so whatever the way I'm giving you question during the explanation also separately also, that they are only the beneficial for you. Okay, so just reading the notes you will be feeling boring and you will not understand how the questions will be coming. Okay, so here bromine minus, when treated with concentrated acid, brown vapors are emitted. Brown vapors may be due to Br minus, may be due to formation of NO2. To further confirm, brown vapors are passed through H2O. If they give brown coloration to the water, that is Br minus. If no coloration, that means NO2. Okay, differentiating Br minus and NO2 is okay. Second observation, when it is salt is treated with AgNO3, light yellow precipitate is obtained. So it is difficult to differentiate light yellow and white color. So it may be due to Cl minus, it may be due to Br minus. To further confirm, it is reacted with NH4OH. If it is completely soluble, that means it is properly white color and the negative ion available is Cl minus. If it is partially soluble, the negative ion available is NH4OH. So this is the observation, and this type of questions only will be there in examination. So how it will be written, that I will tell you through the one of the question. Okay. So now we will explain this same observations but with the chemical equations. Okay. Okay. Here next the explanation of the observations we made. What is the first observation we have made? Brown vapors. So brown vapors observation is explained in the two steps. Here we are using the concentrated sulfuric acid. Okay, concentrated sulfuric acid, that means it can react again and again. If it is dilute, means it will be consumed in the very first step. So in the first step, given salt containing the Br minus when treated with sulfuric acid will produce sodium sulfate and hydrogen bromide. It is just a double displacement reaction. The HBr which is formed in the first step, as we are taken concentrated sulfuric acid. So concentrated sulfuric acid is more in quantity. Therefore, it reacts further to form Br2 gas and SO2 gas. The brown vapors is attributed to Br2 and SO2. Okay. So the same color is also possessed by the NO2. Then we will pass this gas through the H2O. If it produces brown coloration, that means it is Br2, that means Br minus is available. Okay. Second thing what we observed, light yellow precipitate. When given salt, if it is contained, see here, salt is treated with sulfuric acid, salt is treated with silver nitrate. Okay. So silver nitrate when treated with sodium bromide will form light yellow precipitate of silver bromide. Okay. So then if it is dissolved in NH4OH, if it is soluble, that means it is AgCl. If it is partially soluble, that means it is AgBr. Okay. So the observations made is explained with the chemical equations. Okay, here iodide. Iodide is I minus. Okay. So I minus is dark colored violet fumes. When it is treated with concentrated sulfuric acid, what happens? It gives the dark color white fumes, which is due to the I2. That equation I will tell you. First observation, when the given substance, given salt treated with concentrated sulfuric acid, what we will get? Dark colored fumes. Second, it gives the blue coloration with starch. Whenever iodine is there, the best method to identify iodine is starch. Okay. Next, yellow precipitate. Three colors: white color, light yellow, and yellow color. White color means it is Cl minus, light yellow means bromine minus, and complete yellow means AgNO3. So they are all similar color. Light yellow, and white color are very similar. To further confirm what is substance used, ammonium hydroxide. It is completely soluble. It is completely white and Cl minus. If it is light white, light yellow and partially soluble in NH4OH, it is Br minus, and it is completely soluble, and it is completely completely insoluble in ammonium hydroxide and dark yellow, then it is iodine. The main problem with the chlorine, bromine and iodine is the similar color obtained when reacted with AgNO3. Okay, all are similar: yellow, light yellow and white. Pure white is Cl minus, light yellow means light yellow means so if it is complete white and completely soluble in NH4OH, it is Cl minus. If it is partial white or partial light yellow and partial soluble in NH4OH means Br minus. If it is completely insoluble in NH4OH and complete dark yellow, I minus. Okay. Reactions, observations are same. Okay. This is about the observations. Now we will study about the same observation with the chemical reaction explanation. Okay, observations we have made. First, violet coloration vapors. Okay, so violet color vaporations are again concentrated sulfuric acid. That means we can write it in the two steps. Given salt containing iodide minus when treated with sulfuric acid will form sodium sulfate, and sodium sulfate when treated with HI, that it results in HI, that HI will react with some more sulfuric acid which will evolve iodine. Already iodine contains violet colored vaporation. This we have discussed in the previous one of the dilute acid test also. Okay. So there I mentioned iodine is to be tested with the starch paper which converts the starch into the blue color. Okay, so starch paper will be turned into blue color. Then sodium iodide with AgNO3. Sodium iodide with AgNO3 will give AgI. Okay, so which is yellowish in color. And to test the yellowish color, it is treated with NH4OH plus NaNO3. Okay, I2 plus chloroform. It will give you the violet coloration. I2 plus chloroform will give you the violet coloration. These are the chemical equations explaining the observations made. Okay. Okay. Next is nitrate, NO3 minus. Don't think that already we have studied. We have studied is NO2 minus. It was nitrite. Okay. So NO3 minus is NO nitrate, which is when treated with concentrated sulfuric acid, brown smoke will be evolved. What is that brown smoke? That I will tell you through the equation. Next, that brown smoke or the given salt can also be identified by the ring test or brown ring test. Very, very important. V to the power of infinity important. Very, very important. Brown ring test. Okay. I think already you have studied in coordination compounds. In the coordination compounds, you will get oxidation number question. Okay. Oxidation number of metal and oxidation number of ligand. Okay. So what is that? I will try to discuss here also because brown ring test is very important. Okay. So these are the observations made when the given salt is treated with concentrated acid. Brown smoke will be evolved and it gives positive test in the brown ring test. Okay. Okay, what observations we have made? First observation is evolution of brown vapors when given substance heated with concentrated sulfuric acid. Okay, so if the nitrate ion is present on treating with concentrated sulfuric acid, NO2 is evolved, which is the reason behind the brown coloration. Which is the reason behind the brown coloration. Okay, that is the first. That is not much important. Already we have studied so many times. Very important is this one. What is that? Brown ring test. Okay. In brown ring test, the given salt is treated with freshly prepared. What prepared? Freshly prepared ferrous sulfate. Ferrous, FeSO4, Fe plus 2. Then NO. What is NO? Nitric oxide. Nitric, not acid, nitric oxide. Every word is very clarity should be there. Nitric oxide, not acid. Nitric acid is HNO3, nitric oxide is NO. So that nitric oxide formed in the first step further react with some more ferrous sulfate to form this complex. To form this complex. This is called as a brown ring complex. What it is called as? Brown ring complex. Plenty of questions will be there. Brown ring complex. There won't be any direct question. Okay. So in olden days, like 5 to 6 years back, the question used to be what is the chemical formula of brown ring. So this is the answer. FeH2O5NoSO4. Nowadays questions will be what is the IUPAC name of brown ring. Okay, so that you can write it or not. Penta aqua, like that you can write it. I think already we have studied in the coordination compounds. Now the question is about, now the some more depth is increased as the exam is to be conducted now 5 to 6 shift, sometimes last time 8 shifts. So questions are to be in depth nowadays. Okay, now the question is oxidation number of iron in brown ring test or brown ring. Okay, start. Here this is specially I will tell you everything. There are 3 types of anticipated questions. How many types of anticipated questions? Fe H2O 5NO square bracket close SO4. Okay, so this has to be -2. That means it has to be +2. So most of the student what they are thinking it is +2 only. Iron will be +2 because NO exists. The very problem is with no, not no. It is nitric oxide. Okay, it can be 0 also. It can be +1 also. Okay. So it all happens. Brown color is just because of reduction. Because of what? Reduction. Who is the person making reduction? NO. NO is a reducing agent. Okay. It itself will oxidize from 0 to +1. That electron will be transferred to the iron. Okay. Question will be there in the advanced examination and AIMS examination like that. So what will be the electron transfer takes place from NO to Fe2 plus. So because of that, this oxidation number changes from Fe +2 to +1, and it will change from 0 to, it was already 0. So now it will change to +1. Okay. Oxidation number of iron changes from dash to dash. That is +2 to +1. Oxidation number of NO changes from dash to dash, 0 to +1. Okay. Brown coloration is due to this electron transfer only. Okay. For this electron transfer, some energy is required. So in the VIBGR, okay, this is the complete color. What is the color of the VIBGR? Who will tell me what is the color of the VIBGR? It is white color. Okay, when you mix all colors together, then we will get white color. Okay, but this electron transfer requires some energy. So that requires all colors except which color? Brown color. So brown color will be emitted and rest all energy will be absorbed and utilized in transferring of this electron. Okay, any doubt? So this is the toughest possible question. A very simple question, maybe IUPAC name. What is the coordination number of iron in the brown ring complex? Like that, simple questions may be there. So these are the possibilities. I think everybody noted. At least before going the examination, everybody should be aware of the formula of the brown ring complex, oxidation number before and after. Okay, is it understood? So we are left with only one more acidic radical, that is none other than sulfate. What is the next one? Sulfate, SO4 2 minus. Okay, SO4 2 minus is sulfate. Okay, so observation, very simple observation. Small amount of substance. Here already we are using concentrated sulfuric acid. Therefore, to avoid that, what we will do? Small amount of, what amount of? Small amount of substance substance plus given salt plus HNO3. Okay, what is that? That is also concentrated HNO3 heated together. Then BaCl2 is added. Okay, then it results in white PPT. It results in what? White PPT. Okay, so this is the checking to and identify the presence of sulfate. Okay, SO4 2 minus. SO4 2 minus is identified by given salt treated with HNO3. Whatever it is resulted, that is treated with BaCl2, which will result in the formation of what? White precipitate. Okay, so the reaction is Na2SO4. This is the salt containing sulfate. When it is treated with nitric acid, it will result in NaNO3 and evolves H2SO4. Just displacement reaction. This H2SO4 then further treated with what? BaCl2. Okay. So BaCl2, what it is going to form? BaSO4, which is the white precipitate. Okay. White precipitate formula is BaSO4. Is it understood, all of you? So this is about the acidic radical identification. Identification of which? Acidic radicals. Okay. All of you are clear and maintain proper notes, I hope. Okay, now let's do one model question. How the questions will be there based on this. Okay. Let's start with first question. Na2C2O4 plus H2SO4 gives A, and Na2SO4 gives A and Na2SO4. Okay. And when treated with, when heated, H2O is evolved plus X plus Y. Two substances are evolved. Okay. So this X burns with blue flame. Burns with blue flame. Blue flame. Okay. And Y turns lime water milky. Y turns lime water milky. Okay. Identify X and Y. Question is, what is X and Y? Okay. Is this question clear? You can give a try, then listen to my explanation. Very simple question. See, Na2C2O4 plus H2SO4, double displacement reaction. Sodium will go here, hydrogen will come here. Okay. A is what? Oxalic acid, H2C2O4. What it is? H2C2O4. See, simply what you have to do, you have to eliminate water. So easily given. Okay. So H2C2O4, people are writing like this. How they are writing? They are writing like this. Okay. So then see, if you remove the water, what is left over? CO and CO2. Okay. Mainly, which is Y, which is X. So one is CO, one is CO2. Main problem comes which is X, which is Y. Okay. So turns milky white. That means CO2 is Y and CO is X. Okay. So X is CO and CO2 is Y. Is it clear? How the questions will be coming and how you should answer. Let's do one more different model of question. Okay, next question is, which of the following give yellow turbidity? As soon as you listen about the yellow turbidity, one should strike into your mind. With dilute HCl, when the given substance treated with dilute HCl, which is going to give you the yellow turbidity. Okay, right. Okay, see, I will tell you, whenever turbidity is there, that is due to the colloidal sulfur. Why turbidity means partially light will be passing through it and yellowish in color. Okay, so sulfur will be available. Yellow turbidity, immediately what should strike into your mind? It is the colloidal sulfur. Okay, colloidal sulfur will be formed in the S2O3. Okay, in S2O3 2 minus. I will tell you the reaction so that in future some different questions may be framed. So SO3 2 minus plus 2 HCl. When this is treated, then SO2 will be liberated. That is not a problem. What it is? Suffocating smell. You should remember suffocating smell. Okay. 2 chlorine minus will be evolved and colloidal sulfur. This is the reason for the yellow turbidity. Colloidal sulfur plus H2O. Okay. So sulfur it is liberated is colloidal sulfur. Is it understood? Which of the following gives yellow turbidity with dilute HCl? Dilute acid group is S2O3 2 negative. It react with HCl to form suffocating sulfur dioxide along with the S. S is of the colloidal nature. And what is colloid? You will study or studied in the surface chemistry.